Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi. How are you guys? Let me know that sound quality, picture quality, everything is fine. Shreyans Sharma or other students? Yes, please. Okay, 1 minute. Now, so this is a GATE 2024 question from Subjectwise Chapter-2. Okay, and now it is basic laws. Now we will solve some questions on based on what KCL, KVL and source transformation. Okay, and ready to solve some questions, then please everyone please bring your rough copy, pen and calculator, everything. I think all are ready to solve some important question, unsolved numericals from Alexander and Sadiku. Okay, then without any delay we will start this session. That is the question from Sadiku, and this is my introduction for new students. Myself Sanjay Rathi. I am having around 23 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks, and I have trained more than 1 lakh students for these competitive exam, guys. Okay, to practice as much question as possible and try to solve questions from standard textbook. Then this is my Telegram channel. After the session, I will upload the PDF of this session, and for daily dose to improve concept, if you want to give the quizzes, if you want to answer some question, then this is for you. Electronics by Sanjay Rathi. आप यहाँ पर अपने doubts भी रख सकते हैं. Then, and that is very important information for you guys. On 20th October, that is the 22nd October, 9 AM to 9 PM, means for 12 hours window will be open for National Scholarship Test. Get up to 90% off on our program. Register now for this. So what is the registration process? First of all, install BYJU'S exam prep app from Google Play Store, right? And then register for this and give mock test. This is free of cost, and check your ability. कितने पानी में है आपको पता चलेगा. And if you are getting the rank, then get up to 90% off on our program and you can start your journey with us. And guys, by Richa ma'am, free workshop, detailed preparation strategy to GATE 2025, live workshop on 25th of October at 7:30 PM. So you can join this workshop. Then guys, okay, sir, please tell me that ESE non-tech subject can I cover from 1 minute. So now this is the first question, guys, on your screen. Okay, tell me, first of all, give me the answer. Prakhar Srivastava and all other students, a very good evening. Now, this is a question. This is a question from Sadiku, unsolved numerical. This is the 2.25 in chapter 2, unsolved numerical from practice, and then exercise. And this is the figure number 2.89, that is from the 5th edition of Sadiku. And this is the simply find the current, find the power associated with the 20 kilo ohm resistor, and what resistor you have to find, right? And then remember this one that will confuse you, but this is the voltage controlled current source. Voltage controlled current source, this is I, and that is given by alpha V naught. What is the alpha is equal to I upon V naught, that is given as 0.01 ampere per volt. The unit is not given, just I am going to give you the unit, that is the ampere per volt. Now find the value. I am fine, Pandey, 0001. How are you, Pandey ji? Okay. Yes, you can cover practice question, previous year question from 2017 to what up to latest pattern 2023, and then you will get the short notes for what current affairs, and you can follow our lectures, this year lectures, last year lectures, then you can cover general studies. And remember, smart work is required, minimum 100 marks, 80 to 100 out of 200. Then first of all try for this. If suppose you are getting the 120, then well and good, but try for this marks in current affairs, general studies. Okay, Prakhar. Then this is the value. Now how we can solve this question? For the network in figure, this is the first question from Alexander and Sadiku. All are excited to solve some questions? Okay guys. Now, 1 minute. Then first, watch this. Simply 5 milliampere when passed through the 10 kilo ohm resistor. What is the V0? First of all, you have to find the V0. Why? Because this depends upon the V0, dependent source, voltage control current source. So it will become 5 into 10 milliampere cancelled by kilo ohm. Always remember in BJT number of times we have to use 5 into 10 raised to power minus 3 into 10 into 10 raised to power 3. Just we are wasting our time. When we are writing like this, it will be 50. So directly you can say it is a 50 volt. Milli is cancelled by kilo ohm. Now if it is 50 volt, what is the unit of this alpha? Ampere per volt. And that's why this will become, this current source will become 0.01 into 50. And that is 0.5 ampere. 0.5 ampere. This is the value of this current source. And then guys, what is required here? What is asked here? Find the current, voltage and power associated with the 20 kilo ohm resistor. So 20 kilo ohm resistor if you want to find, then you have the value 0.5. Then what is the 20 parallel with 5? You can find that is the 20 parallel with 5, that is 100 upon 25, that is nothing but 4 kilo ohm. If this is the 4 kilo ohm and what is the current passing through the 4 kilo ohm, then you can find the output voltage here. You can find the output voltage across the 20 kilo ohm, that is the output voltage across the 20 kilo ohm is equal to 0.5 into 4 parallel combination, and that is 2 volt. That is 2 kilovolt guys, 2 kilovolt. Why? Because it is in kilo ohm, that's why it is in ampere. This is in 4 kilo ohm. And that's why you will get the 2 kilovolt. This is the value of the voltage across the this 20 kilo ohm as well as 5 kilo ohm. Right? Now Kumar, you are giving the answer, but take care of unit. Take care of unit. Now if the voltage across both the resistors is 2 kilo ohm, 2 kilo ohm, then what is the power across the 20 kilo ohm? You can find the power across the 20 kilo ohm, VL square by R. So it will become 2 kilo ohm into 2 kilo ohm upon what? R. What is the R? 20. Then it will become, this is the 2 cancel out, this is the 10.2 kilowatt. Yes. So we are getting this answer. Please check my calculation also. Then what is this? V square, VL square, that is the square of that, and R is also in kilo ohm. 1 kilo cancel out, and then it will become this value guys. Okay. So that is the answer for the first question. Okay. Okay guys, now I am giving you the hint how to use your, how we can make notes. Sometimes students are asking, right guys? Now watch this. This is the copy. Yes, is it visible to you everyone? This is the blank copy or spiral binding, right? And you can solve what question here? You can solve question, then you can make short notes. And these copies are very, very important one guys. So you can give the number, copy number 1, 2, 3, 4, this copy for network, this copy for digital, this copy for what analog and so on. So that once we are solving question, and suppose we are getting extraordinary question, then we can make notes on those questions on same copy. And during revision, we can use these copies for formula, for short notes, for important numericals. And at the same time, use separate rough copy where you can solve the questions. But use rough as fair copy. Okay, always remember. So I am solving. So just I have solved, for example, I have solved this question and then I am getting the answer that 0.2 kilowatt here. And this is the volt here. Okay, so that is the answer. Remember, take care of unit. Already I have given the unit of alpha. Okay, that is 200 watt or 0.2 kilowatt. Then next one. Is it audible everyone? Everything is fine? Yes, please. Next one. Next question. So power, how we can calculate power, voltage. Now calculate V and Ix in the circuit of figure 2.79. V and Ix. This is the question number 2.15 from the practice. Then this is the 10 volt. This is the V. This is a very because some students are worried about what dependent sources. So this is a current controlled voltage source, and this is Ix. Then what is the, calculate the V and Ix in the circuit. What is the value of V and Ix? Everyone please give me the answer in comments box. Answer in comments box. Okay. Then tell me what is the answer for this question. Now 10 4, this is the 10 volt, this is the 4 volt, means if we are taking it as a reference, so this is the 4 volt, this is the 10 volt, so 10 minus 4, what is the V, is equal to 6 volt. This is the V is equal to what? 6 volt, guys. Okay. Now this is the 4 we have, this is the 4 volt. Now how we can find, this is the already V is 6 volt. Watch this, you can apply the KVL, basic laws from this point to this point, you can apply the KVL. So what is the voltage at this point? 4 is equal to, this is the 16 plus 3Ix. So we are writing the KVL, 4 is equal to 16 plus 3Ix. So what is the Ix is equal to 4 minus 16 divided by 3, that is the minus 12 divided by 3, and you will get the minus 4 ampere. Minus 4 ampere is the value of Ix. Okay, this is the answer for this particular question, guys. This is the value. Okay then. Now, to Bhanu Prakash, everyone please participate and give the answer in comments box. I think this is clear to you. This is a very, very easy question. But what we are doing silly mistakes. So you can solve this type of question, 30 to 40 question very quickly within what, 20 minutes. Try to solve this type of questions within 20 minutes. So that in practice, what are the shortcuts, how to apply the KVL, KCL, voltage division, current division. So first, second and third chapter is just for your practice, and we are getting question 1 mark question and 2 mark question. Now next one, this is the question 6 volt and what, minus 4 ampere. Then this is the question 2.35, practice problem 2.35. Calculate V0 and I0 in the circuit of figure. V0, this is the voltage V0 and I0 in the circuit. Okay, then Manoj, okay, tell me what is the V0 and I0 in the circuit, guys. Now we are having the different methods. One can solve by using what, these two resistors are in parallel, these two resistors are in parallel, then they can find the I equivalent, then what is the current here, and then they will use the current division rule and so on. But can we use a direct KCL, Kirchhoff's current law here? Then everyone try to solve this question. This is again question from Sadiku 2.35. Then watch this. How to find the V0? First of all, you can take Vx here. This voltage is Vx, this is short circuit, that's why this is also Vx. But there is no resistor, current can flow from this point to this point. And what is this voltage? 200 volt. Because it is short circuit, this is the 200 volt. And this is ground. Now we can apply the KCL to find the Vx. So what we are doing, just write down Vx minus 200. This is called KCL, Kirchhoff's current law. All the current Vx minus 200 by 70 plus Vx minus 0 by 20 plus, now right here, okay, so you can write here because this is the same node. We are not writing I0, just we are equate, or we can also find the I0 and we can equate, or otherwise you can directly write Vx minus 200 by 70, Vx minus 0 by 20, Vx minus 200 by 30 plus Vx minus V0, Vx by 5, Vx minus 0 by 5. So you will get this value 0. From this Okay, you can take LCM. For example, just I am taking the 210 as LCM. So 70 into 3, this will become 3Vx minus what? 600 plus, it is not divisible. Okay, no problem. 21 is divisible by 2, that is the 10.5. This will become 10.5 Vx plus 210, 37, 7 Vx minus 1400. 2 into 1400 plus what? This is divisible. Yes, this is divisible. How many times? 42 times. 42 Vx is equal to what? 0. This 210 will become 0. Now watch this. 3 Vx, 10.5 Vx, 7 Vx, 42 Vx. Can you add 3? Try to avoid the mistake. 7 plus 3, 10. 42 plus 10, 52. 52 plus 10, 62.5. 62.5 Vx is equal to 600 plus 1400, that is the 2000. And guys, Vx is nothing but V0. What is the answer? Vx is nothing but V0. What is the answer for this question? Tell me. What is the answer for this question? Quickly. So you can find the value 2000 divided by what? 62.5, and that is what? 32. Answer for this question is 32 volt V0. Yes. So this is the 30. So we can apply the KCL. Right now, what is asked here? I0 is also asked. So how we can find the Ix? Now we have the Vx value. So Vx value in one step we can solve. Then once you have the idea about the Vx, then this current is let I1. What is this? 200 volt. This is 32. And this current is let I2. So I1 is coming, I2 is outgoing. So what is the I0? I0 will become I1 minus I2. I0 will become I1 minus I2. Then we can write I0 is equal to I1. 200 minus 32 divided by 70 minus 32 divided by 20. 32 divided by what? 20. So use your calculator or any other things, and then you can find the value of what? I0, guys. Okay, then please find everyone what is the answer for this question. So you will get this is 2.4 minus 1.6, and that is 0.8. And what is the unit here? Ohm, and that's why it is in ampere. Unit 8.8 ampere. Okay, in this way we can find same calculation in what? Diode circuit. In analog there was the same calculation. How this question is very important, because in the same question one diode is connected here. And what is asked? What is the current through the diode? And definitely what about the diode? This is forward bias or reverse bias? So by this is the 200 volt, we can assume that the diode is forward bias. Once the diode is forward bias, find the current. This current is positive 0.8 ampere, and that's why our assumption is correct. And when we are connecting the diode, it will become 2 mark question, or when the diode is not there, it is 1 mark question. Are you getting my point, everyone? So that is the same question we can expect in what? Analog also. So that is, we can apply the KCL here, find the Vx, and then you can find the current here, and that is the method how we can find the current here. 0.8 ampere. Okay, next one. Next question. In between I will give you the idea how the network is related to what? Analog or other subject. It will boost your confidence. Okay, next. Now find I in the circuit of figure. This type of question, now very quickly you have to solve. Very quickly you have to solve. Asutosh, one day I am taking class, and one day Rakesh Talreja sir will take the class. So in between, Asutosh, you have the Sadiku, Alexander and Sadiku 5th edition, because we are solving what? 10 or 20 questions. But just you have to solve remaining question. So one day break is required. Are you getting my point, everyone? And solve those question which has answer. हम लोग के पास ना कुछ लास्ट कुछ क्वेश्चन सेलेक्टेड क्वेश्चंस के ना लास्ट में आंसर दिए हुए हैं, तो उसको सॉल्व करो. उसको सॉल्व करते जाइए. अब देखो जरा क्या होगा. नाउ what is the parallel combination of 20 and 5? Remember, this is the 4. What is the parallel combination of 15, 15, 15? 5. And then what is the parallel combination of 24 and 8? Now guys, remember, what is the common in 24 and 8? Everyone tell me, what is the common in 24 and 8? 8. Then when it is 8, when I am taking common, it will become 1, it will become 3. So what is the parallel combination of 24 by 8? You are what we are doing, 24 into 8 upon what, 24 plus 8, then it will become 24 into 8 divided by 32, then it will become 4, then we are getting the answer 6. Okay, that is the method. That is the method. But can we do directly? What is the common in 24 and 8? 8 is common. Now once the 8 is common, 24 parallel with 8, that is equal to 8 is common, 3 parallel with 1. Now 8 into 3 into 1 upon 3 plus 1. That will become 2 into 3. That is equal to what? 6. Again you are getting the same answer. So that is way, in this way we can save what, 10 seconds only, but that seconds, 5 seconds or 3 seconds. Okay, so that is the, when we are having the two things, for example 5 and 20. So 20 parallel with the 5, what is common here? 5. So it will become 5 parallel with 1. And then it will become 5 into 4 upon 5. That is, what is the answer? 4. Quickly we can give the answer for this question. Now it is very easy one, very easy. Then this is the method. 2.5 is the correct answer for this question, because this is 12. What is the parallel combination? Just I am giving to remove this 4. This is the 5. This is the 5 ohm. This is 5. This is what? 6 ohm. So 12 plus 4, 16 plus 5, 21. 21 plus 5, 26 plus 26 plus 22, 80 divided. Okay, calculate it. I am doing mistake now. Yes. Now .5 ampere, everyone, you are getting the answer? Yes, that is the correct answer. That is the correct answer here. Okay. This is 32 total resistance, 80 divided by 32. Easy? Okay. Now, next one. Next question. Find Vx in the circuit of figure 2.85. Find Vx. Okay. Give me answer, everyone. Now, this is the question 2.21 from exercise of Sadiku 5th edition, guys. You can purchase this book also. This is the, if you have the hard copy, if you can book from the library, then it is okay. This is the book, and this is the Alexander and Sadiku 5th edition. I have this book. Okay, so you can solve the question from this. How we can store the energy in resistor? Tell me. It is a resistor is what? Energy dissipative, not storing element. We can store energy in what? Capacitor and what? Inductor. Because when we are giving the current here, it will dissipate the energy in atmosphere. That is the I square R. I square R, this is the power dissipation, or into time means energy dissipation you can find. It can't store the energy. Right. Now, this one. Find the Vx in the circuit of figure. What is the Vx? Then again we are having the dependent source, and you have to find the Vx. This is the 15 volt battery, 1 ohm, 2 Vx, 5 ohm, 2 ohm. These all are in what? Series. Then now we can solve like this. This is I. Let this current is I. So what will be the Vx? Vx will become 5I. 5I. Vx will become 5 into I because the current will enter like this. In series, the current 5I. And this 2Vx will become what? 5I. Then 5 into 2, this will become 10I. This will become 10I. Okay. Now write down the KVL. This is the minus 15 plus 1I plus 10I. This is the plus minus 10I. This is the KVL. Plus 5I plus 2I is equal to 0. Now 10 plus 1 11, 11 plus 5 16 plus 2 18I. 18I is equal to 15. So what is the I is equal to? 15 by 18, that is divided by 3, 5 by 6. 5 by 6 ampere. Now what is the Vx is equal to? 5I, to 5 into 5 by 6, that is 25 by 6 volt. 25 by 6 volt. Okay, 4.167 up to 3 digit. Try to give the answer up to 3 digit. 25 by 6. Okay, now this is so very simple one. You can change the dependent sources. Now it is a dependent source is converted into terms of what current here, because we have find the Vx in terms of current. Then first of all find the I, and then you can find the value of Vx, because in series the current will remain same. Okay, so Akanksha, you have used the all other students, Manoj, Bhanu, you have used the different method or same method? It depends. It depends upon your practice. You can use the different methods also, but get the right answer. Now this is we are applying the KVL here. We are applying the KVL here. Kirchhoff's voltage law. Then now that is the question, guys, on star delta. Right, star delta here. So star delta is what? This is the you can use here. Just I am giving the hint and where we can use. Now in this question, how we can use, that is the question number 2.53 star mark question, and this is the figure. Then this is again from same book. How we can solve this question? What is asked here? Obtain the equivalent resistors RAB. Here you have to find the RAB in each of the circuit of figure 2.117. This is the A, and in what all resistor have a value of 30 ohm. Here all resistor have the same value of 30 ohm. In A all the values are given, in B all are 30 ohm. Then first solve A. And one, now watch this. How we can find this? First of all, this is the 30 40. So how we can break? You can convert this into what? Delta. Let this is R1, this is R2, and this is R3. Once you will get the R1, R2, R3, remember this R2 and 60 ohm are in parallel, this R3 and 50 ohm are in parallel, and then you can remove the 30, 40 and 10 ohm. Then it will become, you can minimize the figure here. Watch this. This is 20 ohm. Then this is the 60, and you have to find the R2. Then that is the 50. Find R3 parallel to this 50, and then here we are having the 80 ohm. And there is a one more resistor here that is connected at this point. This is the R1. This is connected parallel to this. This is the R1 connected parallel to this, and this is 20 ohm. Now it is very easy to solve. Then what is the value of R1? So in a star to delta conversion, first of all multiplication of this 30 into 10 plus what 10 into 40 plus what 40 into 30. Numerator will always remain same, and if you want to find the R1 opposite that 10. So this is the 300 plus 400, 700 plus 1200, 1900 divided by 10. So what is the value of the R1? You will get 190. Okay. Then what is the value of R2? Now what, this numerator will remain same, 1900 divided by what? Which one is opposite to R2? 40. This is the 40. That is cancel out, and 190, that is 95 by 2 or 47.5. This is the 47.5 ohm. Then what is the R3? Numerator will remain same, 1900 divided by, which one is opposite to R3? 30. This is the 30, so you can divide it by 30. Now 190 divided by 3, that is the value of R3. Okay. Now you will get this value 190 ohm. First of all, check you are comfortable with star delta conversion. Yes, you have get the same answer. That is one question. Star to delta conversion. So star to delta in practical problem. So this is the star and we are converting into a delta. So R1, R2 and R3. So multiplication of these three and opposite resistor. R1, R2 and R3. Now once you will get the R2, now you have to find the parallel combination of 95 by 2 and 60. Then in next, watch this. Now this is the value. These two parallel, and then R1 190 is parallel 80 ohm. Okay, and this is 190 is parallel, and this is the 20 ohm. Now you can find the value. I'm just directly giving you the value. Please everyone try to solve this question. So what is the parallel combination? What you are getting? 47.5 is the one resistor, that is the, or we are getting the parallel combination 26.51 and 27.94. Check my calculation also. Now when we are calculating, these two resistors are in series. Right now this resistor is parallel to 190 kilo ohm. Then again you have to find the parallel combination. Series combination, then parallel combination, and finally you have the three resistor. This is the 80, 20, and it is approximately 42.89 or 42.32. It is unsolved numerical. So this is the total R equivalent will become 142.32 ohm. 142.32 ohm, guys. So step by step, first, second, third, and so on. Finally you will get the RAB 142.34. Okay, so it will take time, and that's why practice how quickly we can solve. So this is how. Okay, you got the answer, Bhanu? Okay. If suppose we are solving, or suppose we are doing the silly mistakes, then please check whether we are doing the what is the problem. ऐसा एग्जाम में आप चेक नहीं कर पाओगे ना, एग्जाम में क्या क्या गलतियां होती है आप यहां पर बनाएंगे. पूरे प्रॉपर सिस्टमैटिक कॉपी का यूज कीजिए. मैंने कहा ना, ये देखो, ये आपकी प्रैक्टिस के लिए मैंने भी खुद सॉल्व किया. देखिए आपके सामने तो मैं एकदम नीट एंड क्लीन सॉल्व कर रहा हूं, लेकिन यहाँ रफ कॉपी में देखिए पता नहीं क्या हो जाता है. आप एकदम कैजुअल लेने लगते हो, और जैसे ही हम कैजुअल लेने लगते हैं चीजें गलत होने लग जाती है. यस, यस और नो? ये आपका भी एक्सपीरियंस है कि मेरा भी है? मेरा ही है. जैसे ही आपने कैजुअल लिया, अरे ये तो हो जाएगा एग्जाम में, और वही क्वेश्चन गलत. एंड 2 + 2 वी आर सेइंग दैट 2 + 2 is 5. हाउ इज इट पॉसिबल? सब पॉसिबल, एवरीथिंग इज पॉसिबल ड्यूरिंग एग्जाम, अंडर एग्जाम प्रेशर. ओके देन, नेक्स्ट वन, next question. So that is the answer for this is 142.33. Next is what? This is a one triangle here, 30, 30, 30 and so on. So what we can do in this question, we can apply the delta to star conversion because all the resistors are same, and when we are converting the delta to star, always remember the impedance because of the Y network or delta star network is always divided by 3 when we are converting. So it is 30, so no need to calculate, all become 10. So can you apply like this? This is 10, this is 10, this is 10. First of all, convert this delta into star. Then already this 3 resistor gone. Now this is convert. This is 10. This is 10. This is 10. Okay, now it is gone. This is 10. This is 10 and this is 10. Now redraw the diagram and all the resistors, all this first delta, second and third, all. Then you can redraw the diagram. Just I am using the technology here. So this is the case. Watch this. That is gone. This resistor gone. This resistor gone. You can remove all these. This is gone. All delta is converted into what? Star, and what is the value? 10 ohm. Now we are having this circuit. Okay, you can redraw the circuit. Now watch this. This is 10, 10, 10, 10. What is this resistor? This resistor is floating. Floating means what is the current here? 0. So you can remove this. This is 10, this is 10, this is 10, and this is the A and this is the B node. Now this 10 and this 10 are in series to 20. 10 plus 10 plus 10 plus 10, 40. And then you can redraw the diagram. You will get now watch this. This is 10. This 20. This is 40. And again 10. This one 10. Now you can find the value. Okay, so this is the series combination, and you can leave the floating resistor, and that is the value. These two are this combination and these two combinations are in parallel. Or during conversion you can also give the node number. Node, for example, you can put the node like this is the M node. It is what? M node. N, L, and so on. So that is the connection, proper connection. And then this is 20 parallel with 40. Already have taken 20 parallel with 40. You can take 10 or 20 as a common. It will become 1 parallel with 4, 1 parallel with 2 only. That is 20 into 2 divided by 3. That is the 40 by 3. Parallel combination is 40 by 3 plus 20. So 40 by 3 plus 20, what is the R equivalent? R equivalent will become 40 by 3 plus 20, that is 60 plus 100 by 3. 100 by 3 ohm. Yes, you can use the concept of symmetry also. Okay. So, but normally what we are doing here, we are using what? Star delta conversion. In 11th 12th we are using the concept of what? Symmetry, mirror symmetry, fold back symmetry, right? It's up to you. But here what we have that method, then we can use. Otherwise you can cut into 2 equal parts from this point to this point. Okay, and then you can apply the concept of symmetry here. Okay. Now next question. Ready for next, everyone? Okay, this is the question. So already we have solved question on what is star delta, 2 questions. Then some practical questions. Why in analog, once I have said connect the voltmeter. So students are saying, I am just asked what is the internal, what should be the internal resistance of the voltmeter. Some are saying 0, some are saying infinite. Tell me, what should be the internal resistance of voltmeter? Give me answer in comments box. Then guys, this is the question on voltmeter. First question, obtain the voltage V0 in the circuit of figure. Very simple. Find the V0, and this is given in 2 milliampere, 5 kilo ohm, 1 kilo ohm, 4 kilo ohm. This is the first question. Again, it is an unsolved numerical 2.67 from Alexander Sadiku. Determine the voltage V0 dash. Determine the voltage V0 dash measured when a voltmeter with 6 kilo ohm internal resistance is connected as shown in the figure B. So here we are connecting the voltmeter, its internal resistance is 6 kilo ohm and it will measure V0 dash in place of what? V0. In place of that it will measure V0 dash. Then what is the value of the V0 dash? What should be the, again Poonam, and that is same question guys. Always remember voltmeter should be connected in parallel and what is the internal resistance? It should be infinite. What should be the current through the voltmeter? It should be 0. So that same current will flow through this and we can measure the voltage. If suppose you are giving the 0 resistance, everyone tell me, if it is short circuit, what will be the voltage? It will become 0. Are you getting my point, everyone? What should be the internal resistance of voltmeter? Ideally infinite, and it should be as large as possible. Okay. Now, so that is the problem. What is the internal resistance of this voltmeter? 6. And what is this? 4 kilo ohm. We want to measure V0, but actually we are getting V0 dash. And that is the question. What is the, calculate the second question, calculate the percentage error. This is the required value, but we are measuring this. So what is the percentage error? Now we are increasing the internal resistance up to 36 kilo ohm. Then what about the percentage error? Guys, remember, when we are solving this type of questions, you will never do this type of mistake. Because when we are increasing the internal resistance from 6 kilo ohm to 36 kilo ohm, if the error decreases, then you can understand, okay, large value of the internal resistance is required. Right? Now, we will solve first question. Obtain the voltage V0 in the circuit. That is a different question. Tell me. Sadiku na, first A part just give for what? Warm up. And then second part, practical application. So this is just for your warm up. Obtain the voltage V0 in the circuit of figure. So just first question. Tell me. This is the 2 milliampere. This is the 5 kilo ohm. 4 plus 1. This is also 5 kilo ohm. Current division rule. According to current division rule, what is the current here? 1 milliampere. What is the current here? 1 milliampere. You can use the current division rule, and this is a 4 into 1 milli. Cancel with the kilo ohm. What is the V0? 4 volt. Directly you can say this is the answer, 4 volt. Just for your warm up. Okay, that is over. Second important question. Second one is the very important one. This is a very easy one. Second question. Okay, where is the diagram? 1 minute. Oh, 1 minute, 1 minute. Yeah, this one. This is the diagram. Right now, watch this. First of all, when its internal resistance is 6 kilo ohm, we have to find the V0 only. So 6 kilo ohm, 6 parallel with 4. What is the parallel combination? 6 parallel with 4. This is 24 divided by 10. That is 2.4. Now this is the 2.4 ohm. You can convert this current source into voltage source. So 5 kilo ohm multiplied with the 2 milliampere, 5 into 2, 10 volt. Kilo cancel with the milliampere. Then you can make this circuit voltage, source transformation we are using. Then it will become, because it is a DC source, 5 into 2, that has become 10 volt. And then resistor in series, this is the 5 kilo ohm. This resistor in series 1 kilo ohm, and this 4 and this is the 2.4 volt kilo ohm. Okay. Now what is the V0 dash? When we are connecting the voltmeter, it will measure the V naught dash. So according to voltage division rule, what is the V naught dash? It will become 10 divided by 5 plus 1, 6 plus what, 2.4, and we want the voltage across 2.4. Then you can measure the voltage. Tell me what will be the answer. What is the answer for this question? And I think you will get 2.875. Are you getting 2.875? 857. 2.857 volt. Check my calculation also. So this is a voltage division rule. Now this is the after connecting the voltmeter. But what is the actual voltage? When we are not connecting the voltmeter, so what is the V naught? Now you can find the V naught here. What is the actual voltage here? Remove the voltmeter. First of all, remove the voltmeter. Then simply for already you have used the voltage division rule. You have source transformation 10 volt. Now it is 4 volt only. This is 5. This is 1. Source transformation 5 and 1, 6, 4. So what is the V naught, actual V naught? 4 divided by 6 plus 4, because it is 6 into 10, and it will become 4 volt. So actually voltage is 4 volt, but we are measuring 2.875. So what is the error? According to this question, what is the error? Error will become 4 minus 2.875 upon 4 actual value, measured value into 100%. And you are underestimating it. You are calculating the wrong value here. So what is the percentage error? And that is a very huge percentage error. 2.875 divided by 4 into 100%. And this is 28.125%. That is very large. Okay. So it will affect, and that is called what? Loading effect. That is what? Loading effect. This voltmeter will load the circuit. It will measure the voltage, at the same time it will affect the equivalent resistance of the circuit. This is called loading effect. Okay. And then guys, so answer 28. Now at the same time, what is the answer? If it is given, we will solve the same question. If it is given, third question, find the percentage error if the internal resistance was 36 kilo ohm. Now we are increasing from 6 to 36. Then you can solve the same question. Just I am going to solve same calculation. Watch this. But you have to change this parallel combination only. This parallel combination you have to change. So now this is the 36 kilo ohm. So 36 parallel with 4. Right? Again, you can do the same calculation, guys. 36 parallel with, you can take 4 as a common. That is the 9 parallel with 1. And that will become 9 upon 10. 3.6. Is it correct? 3.6. For verification, you can also check. Then after that, you can continuously, you can use this method now. 3.6 ohm directly. 3.6 kilo ohm, not ohm, kilo ohm. Now, according to voltage division rule, what is the V naught dash? V naught dash will become 3.6 upon 6 plus 3.6 into 10. This time, because it is a 3.6 kilo ohm, you will get a voltage near to what? 4 volt. And this time, everyone please calculate. Calculation is your part, guys. 3.75 volt. This time you will get 3.75 volt, near to 4 volt. Then what is the error? Percentage error is 4 is the actual value, but we are measuring the 3.7 into 100. And you will get error around 6.25%. That is less than 10%. Okay. Less than 2%, it is okay. Okay, then that is the case. So guys, when we are saying what is the, everyone again I am asking question, what should be the value of the internal resistance of the voltmeter? Ideal value, tell me. What should be the ideal value of the internal resistance of voltmeter? So you can say, sir, it should be what? Infinite, right? You can say, sir, it should be what? Infinite. But practically not possible. Practically not possible. So what is the practical solution I am giving you? In interview, it will help you. In interview, in objective, it will help you. For example, its internal resistance should be as high as possible. We are giving ideally it should be infinite. Okay. In first case, we have chosen 6 kilo ohm. So what was the percentage error? 28%, nearly equal to. Then in second case, we have increased it up to 36 kilo ohm. Then it is error is 6.25%, that is less than 10%. Okay, so what is the conclusion? We are saying that it should be infinite, or practically it should be high. It should be as high as possible. Tell me, this line is bigger one or smaller one? We can't say about this line because it is a comparative term. So what we are doing, we are comparing with the second line, right? That this is the red one. Yes. Now we want to measure the voltage across the 4 kilo ohm. Initially it was 6 kilo ohm. It was what? 4 kilo ohm. Its internal resistance is 6 kilo ohm. It's 4 kilo ohm. And that's why it is large, but it is not so large. And that's why we are getting a very high error here in first case. Second case, what we are doing, we are not taking it infinite. We want to measure across the 4 kilo ohm. What we are doing, just simply we are increasing our line. Now, what is the value of this line? 36 kilo ohm. This is the 6 or what? 9 times higher than that. 9 times higher than that. So, normally we are taking 10 times higher or what? Approximately 10 times higher. Then we can neglect that, the effect of that resistor. So, in interview, definitely they will ask. You will say, sir, it should be large. It should be high. So, then they will ask, large means what? This large, that large. It should be large as compared to this resistor where we want to measure the voltage. So this is very, very large, and that's why the error is very, very small. For example, if it is 4 mega ohm, then we have to choose the internal resistance what? 36 mega ohm. Okay, that is the case. Okay then. So these all are the practical problem. Last one, the practical problem again. Have you used what? Electric sharpener? Anyone ever used electric sharpener? कितने लोगों ने electric sharpener का use किया है? हाँ, comparatively it should be large. That should be the practical value. Now it is an electric pencil sharpener. Again, this is the 2.79 textbook question. Rated 240 milliwatt. 240 milliwatt. It is the rating of this. And what is the maximum voltage? 6 volt we can apply here across the electric sharpener. Is connected to a 9 volt battery, but only the 6 volt is required here. The 9 volt is greater than 6 volt. Sorry, calculate the value. So what we are doing, we are using the series resistance so that extra voltage will drop across the RX. Calculate the value of the series dropping resistor needed to power the sharpener. Now, here it is 9 volt, here it is 6 volt. So what should be the voltage across the RX? 3 volt. Now you have the voltage 9, this is 3 plus 6. Then, if you want to find the value of RX, in number of cases you have to find the value of the unknown resistor. Always remember voltage across that upon current through that resistor. Voltage across that is like 3 volt, this is Vx, and what is that? Current through the resistor, then you can find the value. Then what is the current? So how much current is required through the sharpener, right? Because we are not having the resistor value. So how much current it will allow? Then power is given, voltage is given. What is the power rating is equal to voltage into current. So what is the current is equal to power by voltage. So it will become 240 milliwatt divided by 6. So it will what? 40 milliampere. 40 milliampere is the current will pass through the sharpener and pass through this circuit. Now we have the value of the voltage, you have the value of the current. What is the value of the Rx? What is the value of the Rx? Then you can find value of the voltage 3, value of the Ix 40 milliampere. Remember milli, it will become 3 upon 40 into 10 raised to power minus 3. That is nothing but 3000 upon 40 ohm. I have converted this into ampere. This is cancel out, and I think it is 75 ohm. What is the value? 75 ohm series resistance is required in this case. The electric sharpener to reduce the voltage. In number of cases in voltage regulator we are using the series resistor. Everywhere we are using the series resistor like this. In voltage regulator what we are doing? In voltage regulator same concept here. Number of students are highly confused. We are connecting a series resistor here like this, and we are connecting the Zener diode here like this, and now suppose here it is a 50 volt, but the Zener breakdown voltage is only 15 volt. So what about the remaining volt? Tell me. This is the 50 volt, this is the 15 volt. So what about the remaining voltage? 50 minus 15, 35 volt. 35 volt will come across what? Now the power rating of Zener diode is fixed. For example, the power rating is given 50 watt. It can be either 50 milliwatt or 500 milliwatt. Now, so what should be the value of Rs? Now you have the voltage, you can find the current. Once you find the current, you can find the value of Rs. So similar type of questions we are getting in what? Analog. Okay, that is the practice in electrical or other subject. These are the electrical or practical application of all these questions. So why we are not able to solve the questions in core subject? Basics. We are weak in what? Basics. To solve questions, as much question as possible. In network, no problem. Now, this is the electric sharpener practical question. 5 minutes more. Now, this is the information for you guys. And we are taking what? Mega mock test, guys. All India open mega mock test. Now, how many students want to give? So everyone, on my advice, first of all, install, that is free of cost, BYJU'S exam prep app, okay, from the Google Play Store, and where you will get what? All previous year question paper. Directly you can solve free of cost, full complete paper, full length paper. And then what? You can give the mock test, that is the free of cost, All India open mock test from 14th of October to 20th of October. You can attempt now, and that is the this is the test for all the branch, civil, mechanical, electronics, electrical, computer science. But that is the schedule given for what? Electronics engineer. And because I am from electronics, to strive towards the success in GATE, and if you want to crack GATE with top rank, then definitely you have to give the as much mock test as possible, okay, not infinite. Then second thing, class is not over, guys. Then this question, tell me what is the value of V1 and V2 without silly mistakes. Everyone write answer in comments box without silly mistakes. Okay, find V1 and V2 in the circuit of figure 2.2. This is the V1, this is the V2. Now this is given here. Then can you apply the KVL here? Then like this you can apply the KVL. Okay, this value is given, find the values. Just I am giving you the hint. This is the minus 32, you can write. This is the V1, that is minus is given, but value is also given minus 8. Value is given minus 8. So you can say, sir, it is a printing mistake or just it is a symbol. Yes, but you have to choose both things, values as well as minus 8. Then minus 32, this is the minus 32 plus V1 minus of minus 8, this is minus and this is the value is minus 8, minus V2 is equal to what? 0. This is 1 KVL. 1 KVL. Now you can take one current I, then you can find the current here, then directly write with the current, go with the flow, minus 32, 4I with current, you can choose polarity plus minus. This is plus minus, and that is for minus 32 plus 4i minus, because it is minus, and minus 8, value is minus 8 plus 2i is equal to 0. Now this will become 4 plus 2, 6i. On the right hand side it will become 32 minus 8, 24. So what is the I is equal to 24 by 6, 4 ampere, right? 4 ampere. Now tell me, what is the value of the V1? What is the value of the V1? You are giving the V1 minus V2. Okay. What is the value of the V1? This is the current. V1 is what? 4 into 4. 4 into 4, that is what? 16. Volt. Okay. And then what is the value of the V2, guys? 16. And what is the value of the V2? Everyone click, give me the answer. Take care of all the symbols and all this, then write down the proper KVL. Now, if you are giving the minus 8, you have given, yes, Mohan, your answer is correct. Because every time you have to watch the polarity here. This is the plus minus, but current entered through this. So, according to current, what is the Vx? 2 into I, that is the 8 volt. But what is the V2? V2 is minus Vx. That's why it is minus 8 volt. Watch the polarity here. This is plus, this is the minus, and that's why it is minus 8 volt. 16 and minus 8 volt is the answer for this question. So, hope you are enjoying the session, guys, everyone. Then, next information for you, that is leaderboard. If you are downloading the Google BYJU'S exam prep app from the Google Play Store, right? Then, leaderboard, how many number of students participating in course, what is your rank, what is your score. Okay, every detail you will get about the mock test. तो आपको भी लगेगा कि हाँ कुछ किया जा सकता है. Then this is the time for homework, guys. This is the first homework. Solve this question and give me answer on my Telegram channel, that is Electronics by Sanjay Rathi. Again, same type of questions. Because of this polarity, number of students are giving the wrong answer. They are making the mistake in plus minus. Take care of this and try to solve this question. Then another one already we have solved. For the bridge network in the figure, this is the bridge network, but whether this bridge is balanced, yes or no. If it is not balanced, always check this. R1 by R2 is equal to R3 by 4. R4. If this bridge is balanced, then what is the current through the 20 ohm resistor? 0, you can remove it. But if it is not balanced, then you have to solve. Again, you can use the star delta and then find the value here and then find the final current here. First of all, RAB and then current. And give me answer on my Telegram channel or on comments box. You can give the answer. Okay. Then, guys, this is a GATE 2024 crash course. Already we have started for electronics student as well as for electrical aspirants. Now, if you want to crack this exam, okay, then start your preparation now. For more detail, you can call at this number. This is our number, and we are providing you the live classes, recorded lecture, study material, practice quizzes, mock test, everything available here. What is your feedback about this session, about workbook session? Right now, simply try to solve solved example, practice question and some selected question from exercise. No need to solve each and every question. कई लोगों को लगेगा सर मुझे पूरी बुक सॉल्व करनी है तब मेरा गेट में निकलेगा. ऐसा नहीं है जरूरी. That is not, we are giving you the all important questions. If suppose you are able to solve all these questions, okay, well and good. मतलब एक सेट मत करो गोल. Don't set the goal that कि मुझे पूरा बुक सॉल्व करनी होगी तभी मेरा सिलेक्शन होगा. ये सब गलत. जितने आपसे क्वेश्चन सॉल्व हो जाए, जब आपको कॉन्फिडेंस आ जाए कि यार मुझसे बनता है, उतना ही सॉल्व कर लो. 25%, 30%, 50%. ओके, more than sufficient. On this Telegram channel, I will upload the PDF of this session. Okay, then thank you very much for attending the session. You can join this is Electronics by Sanjay Patil. You are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel. Thank you. Have a nice day.